heating, free electricity. What is this? It looks like a distributed data center. Paul Benoit, you guys are making your debut here at CES. Tell us about what this device is behind us.
Yeah, in fact it looks like a heater, but inside it's a large computer, and it's the first computing heater using computers as a heat source. So with this Curvet, the digital heater, we distribute the computing power into homes instead of concentrating them in data centers. So it's a different approach of computing, and with this we can heat people for free. We already heat hundreds of households in France for free for 2 years now, with Curvet, computing remotely for banks, for 3D animation studios, for research labs, for example.
I have a couple questions on this about the technology part, but first about the heating part. So a person just plugs it into their wall, maybe they put it in their living room, and then the heat just radiates out?
Yeah, in fact, the heater have two plugs, electrical plugs and internet plug. So it's a connected heater. You just need to have fiber home. So it's the only need you have to be equipped with this system.
This seems like a great opportunity for anyone who has a fiber to the home network.
Yeah, in fact, we can do that today because we can explode the data center into small pieces because we have a high bandwidth network. Before it was more difficult with a low bandwidth network.
So what happens when one of those nodes fails, say the power goes out?
Yeah, in fact everything is automatic for us. If a node fails somewhere, it's not a problem because we will start the computation somewhere else. So today we already work for banks, for example, for 3D animation studios. Sometimes we can have a problem with a computer somewhere, like in a data center, but automatically the software will restart the node somewhere else.
So what happens though if a node totally fails? Does a repair person have to go out and swap it?
In fact, we never have failure globally. It's impossible because it is distributed.
I meant at an individual home. Say one just fails for whatever reason.
Yeah, it can fail, but we will come and replace. But most of the time, it's just a problem with one computation. It's not a problem with the heater.
Was it a hurdle you had to overcome as far as getting banks and stuff to know that part of their computations are sitting in someone's living room?
Yeah, it's a bit difficult to convince them to use this, but in fact it's the real cloud. If you want to use the cloud today, you must be able to compute anywhere. And this is really what we do with this system. We are able to compute in the heater, so our clients are really like the way we do the cloud, because it's really a disruption. And they know that they won't be able to do computation in data center for a long time at a large scale. And this is a solution for large scale.
And that's an interesting thing. Now, can a bank have its own set of nodes so that only computations from one client will be on this node, whereas my neighbor might have a different one?
Yeah, in fact, this is the beauty of the software system, to be able to switch from a computation for 3D, then to computation for a research lab, then computation for a bank or another bank. In fact, inside we don't do storage, it's just computation. And when the computation is finished for one client, we switch for another computation. Everything is done in memory. It's really the real cloud for computation.
And I'm sure, similarly, if someone actually physically tried to break into it, it would be rendered useless, right?
Yeah, in fact, everything is encrypted for end-to-end. So we use the encryption standards, and it's also the future of the cloud. We need security, and also for the IoT. This device is also the future of IoT and smart building. So we have encryption everywhere.
Well, the neat thing about it is you don't need to worry about backing up power, because if it fails at one place, it's somewhere else.
Yeah, it's the beauty of distributed computation. So we just implemented this at the city scale.
So in addition to computing for others, it'll compute for the home as well, right?
Yeah, exactly. In fact, we realized that we are present in every room, connected to the high bandwidth internet and with power supply. In fact, we can provide a very smart machine in every room of the building. And so we added many sensors inside the heater. You can see all the sensors here that measures air quality, for example. You can have also presence detection, noise level, all these things. And it will provide a really smart building experience inside the home. And you will use also the computing capacity for the home occupants also.
So do you find you have multiple of these in a house, for instance?
Today we have more than 300 in France, and when we deploy this, you have one in every room.
Okay.
Yeah.
So it truly becomes a whole home heater. And then, well, how do these communicate between each other? Is it Wi-Fi or?
No, they communicate with the wire because they are wired to the internet. So it doesn't use the Wi-Fi because we need the wired internet high bandwidth for the computation for our clients. So we can leverage on this, and you have a house, and we can also provide the Wi-Fi through the heater. In fact, we don't use the Wi-Fi; we provide the Wi-Fi.
So you've effectively got a router built into it.
Yeah, exactly.
And then it looks like it has some other capabilities, some wireless charging.
Yeah, for example, you can charge your phone. It's something that you can have in every room with the heater. For example, here you can charge your phone. And you will have a very smart device in every room of your house.
In the U.S., there's a lot of opportunity, particularly in rural areas, for bringing this out with fiber to the home. Are you working with telecom companies who might have the networks?
Yeah, today we have a partner in telecom in Europe, but we are starting to go to the U.S. and look for partners also, mostly for computation, for 3D, for example, for 3D animation, to do large movies of 3D animation in this system is greener and cheaper. So we are really excited to come to US. We already did 3D animation movies in France, and we will start to go to the US, and we hope to do that also in the US.
Excellent, Paul. Congratulations and thank you.
Thank you very much.